In this lecture, we are going to make this girl named Alice bigger or smaller, depending on the food she eats or drinks, or rather on the button we press. This is a perfect opportunity to look at some scaling basics. So, let's get started. When you look at the game object transform, you can easily notice the scale fields. By default, x, y, and z values are equal to 1 for all newly added game objects. And as you probably figure out, the scale is stored as vector 3. Of course, you can modify the scale in the inspector. Rather than that, there are several ways you can modify the scale in your code. The scale displayed in the inspector is a local scale. If you modify the scale of the parent object, the object size will be changed, however the values in the inspector remain the same. You can also get the object global scale by using the transform lossy scale property. Let's run the scene and update our Alice scale. The lossy scale is displayed on the screen. Unlike the local scale, the lossy scale is a read-only property, so you cannot modify it. Since we just started working with the scaling, I must mention that the vector3 struct has a static scale method, which is essentially the same thing as doing the following. Okay, now you can try to do the task. Make Alice big or small using your code. You can use a UI button to trigger a rescaling, or use a keyboard or the onMouseDown method. Just use any options you want to say Alice that she needs to grow or shrink. So please pause the video and give it a go. Okay, so here's how I've done this. First of all, I used raycasting with real models to trigger rescaling, so you could take a look how to use it in your games. This technique is especially useful in 3D games. You can use it to interact with objects that your character is looking to. And if you set the distance of the ray, your character could only interact with objects within his arm reach. My game manager casts a ray from the camera. And if it hits the object with a certain tag, it changes the size of our Alice. The game manager also stores the reference to Alice component, as well as a scale factor. The scale factor will be used to calculate the target scale of our model. Since I don't want to change the scale instantly, I use the math lerp method. As you might guessed already, it allows me to slowly change the scale over time when used in update phase. Let's now look at Alice. She has the Alice component, which stores the target scale property. Also, I track if Alice size is currently changing using isChanging property. If it falls, the game manager is allowed to use the raycast. If it's true, I enable the update to go further. So here's what happens in the game. When you click an object, the game manager multiply or divide the target scale by the scale factor depending on the object tag. The game manager will also set the isChanging to true. Finally, when the resizing is over, Alice will change the isChanging value to false. That's it. In the next lecture, we are going to move Alice around. Stay tuned!